All right. So I am recording. So this is recording. We are going to look at what is a function. Like I say, a function is a relation where for each input, which is an x, there is exactly one output. For each input, there's exactly one output. And often inputs are the x. We refer to the x's as our inputs and the y's as our outputs. So what I mean when I say we have a function for every input. So for every number in x, let's go 3. Oh, wait, let's type this here. 3. I was in the wrong spot. There's exactly one output, 6. If I have the number 2, it'll have exactly one output, 9. I'm just kind of making up some random values. But this is an example. Let me make that a 7 so it shows on the screen. And make that an 8. Notice for every x value, I just have one y value. If I had another x value, let's say I had another 0 that had a different y value, 5. This is not a function because I have one input with 2 different outputs. If you got one x with 2 different y's, it cannot be a function. So that's kind of ties into what I heard people mention the inputs, outputs. So first off, just any questions just about that part? For every input, there's exactly one output. Okay. So even if I made this, so if I had this any other x value, now it's clearly a function because my inputs each give me a distinct output or an individual output. So we can model functions with points. I heard someone say you could use graphs. Yes, quite often, we will use graphs. F of x equals x. This is an example of a function. And partly with this function, it fits that definition of every input or every x has exactly one y value. So no matter what I click, when I look at my x value, there's only going to be one y value that goes with it. So that makes it a function. Another way that we could tell functions, I'm just going to cut this off for a second and get back to that. Another way that we could tell functions is what's called the vertical line test. X squared plus equals 4. Okay. Let's kind of put a random graph up there. In the message bar or message area, chat area, y'all know what I mean, is the circle a function? Do you think that would be a function? Yes or no? Okay. Because does every x have exactly one y? Right, group. Good, 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 good. All right. See a lot of no's, and the no's have it. The no's are correct. Do I have a brave soul willing to explain why? Got a lot of brain power in here, I could tell. I think I got some people know the answer, they shy. remember, for a function, every input should have exactly one output, right? So if I take, oh, okay, maybe. So if I take right here, positive 1. Positive 1, I get a y value of negative 1.73. But up here, positive 1 gives me positive 1.73. So technically, it looks like I have two different x values. Yep. Because I have like 0, 2, and I have 0, negative 2. Anytime your x values repeat, it cannot be a function. Okay, the x values cannot repeat with different y values. So, absolutely right. So, circle cannot be a function. It's a set of points in the plane, but you won't necessarily map to a distinct output. Each input maps, but not to a distinct output. So circles cannot be functions. And this is something that's going to come up a little bit later, kind of a little bit of review. Wait, hold on. Trying to put a slider. Oh, snap. Sorry, went too fast. I was trying to add something in here, and I am having, I swear I did it the other day. F of x equals, let's go 0. Oh no, let's make that 1. So notice this green line. Notice how the green line touches the circle more than once. This is what's called a vertical line test. Any graph that a vertical line, if it touches the picture more than once, is not a function. That fails the vertical line test. It's automatically not a function. Good. See, like I say, a little bit of review because I know we've been out of school for a minute. So trying to get some stuff back in your head. I'm glad this is coming back. So that vertical line test, whenever you see a graph, if it is a function, any vertical line, matter of fact, let me do this graph, 0 and go from -2, because no matter where this graph goes, this is what I was trying to do. As I move the graph, move the line, no matter, it always hits 2 points. Because it's pretty much always, or if it hits 2 points anywhere, it's not a function. As soon as you hit that green line touches more than 1 point, it's not a function, okay? So just wanted to do a little recap on what is a function, what is not a function. And kind of to tie it into what I heard a few people say earlier, we represent functions with graphs. We're going to represent functions with equations. We're going to represent functions with tables. And that's one of the big things we'll do is going between the three forms of representation. All right. Any questions at all so far? All right. Just also a little side note. This is different for me as a teacher and you as a student. Normally as a teacher, when I stop, I have a tendency, I stop and I pause and I walk around and I kind of see what everyone is doing. I no longer have that ability. So you have to make sure it's going to be even more important for you to advocate for yourself. And if there's something that you necessarily might not want to discuss with the whole class, in the chat, if you click my name, it'll be a private message just to me and only I can see it. And I can reply and we can have a private conversation. Okay. So
Excuse me, Mr. Calhoun, may I suggest something?
Yes.
If anyone's doing the meetings on their phones and they have a Chromebook, I suggest you find like a journaling website or app for you to take notes on. So that way, if you want him to see your work, you can like screenshot it or something and send it to him, and then boom, bada bing, just a suggestion. You don't have to, but that's what I'm doing.
No, thank you. See, remember I said we all got to learn through this. This is part of y'all have to teach me some things. Because as I was mentioning earlier, I don't know what a lot of this looks like on the student interface. Because like some of the programs y'all log onto, it looks different. When you see me log in to Reveal, it looks different than yours. I don't know exactly what your experience looks like. So I think it's important that if you have some best practices, share them with your classmates. Share them with me so I can share them with my other classes. I am not gonna get offended. I'm not one of the people, I can't believe you had nah, if you got a suggestion, especially, look, I wouldn't have thought of that. So my whole goal is I want y'all to learn. In the end, that's all I want y'all to do is learn. So whatever it takes to help you learn, do it. That's what I'm about. Okay. I am going to continue. I just want to go a little bit more, maybe about 5 more minutes. I'm going to give you some time to work and give you some time for some questions. And I'm going to continue a little bit on, not continue a little bit, but continue on Thursday. But I just want to, like I say, recap a little bit about what is a function, which we just did. But I just want to talk right now about 3 specific types of functions. So you might want to write these down somewhere if you haven't. I want to talk about 3 specific types of functions that we're going to come back to. But the first type of function is what's called a constant function. Constant, C-O-N-S-T-A-N-T. And a constant function is written like, for example, I have the constant function y equals, let's make that y equals 1. Oh, something else I'm gonna do real quick just to kind of help me a little bit. Let me get rid of some of these lines. Okay. Now, come on, computer. Now you see the constant function is this orange, this red color, whatever. It only has y equals just a constant. Constant just means something without a variable, just a number, a real number. Whenever you have a constant function, even though I'm moving these values around, what do you notice about the line? Whenever it's constant. Anything you notice about that line?
It's one straight horizontal line.
It is always going to be a straight horizontal line. Always. Any constant function, all constant functions will be perfectly straight horizontal lines. And technically, this is a function because each x value will only give me one y value. That's what makes it a function. So often you will see these functions written in the form, I'm gonna give you a couple of different forms you'll see them. Sometimes you might see it as y equals a, where a is just some value, some real number. Another way we'll write it sometime is what we call function form, function notation. And then just for, wait, what's this one? Y equals a. Oh wait, I take that back. That one won't come up like that. I take that back. That one won't, is it giving me a? Yeah. I don't know why I did y equals a like that. But notice, even in function form, it's the exact same thing. Just a horizontal line. So one of the functions I wanted to make sure that we kind of review, constant, all right? Any questions on constant? Okay, straight line, real number, straight line. All right. The second type of function that I want to explore, take you back to whenever this was, linear functions. Linear functions. Straight line. Or bring it back to whenever you might have first learned it, y equals mx plus b. Y equals mx plus b is your base linear function. And just in case you forgot, the m represents the slope. That talks about how angled the line's going to be, how slanted. Is it going up? Is it going down? And b is your y-intercept. So for this blue line, you know, as my slope gets more negative, it kind of rotates in a clockwise direction. And as it gets larger and positive, it goes in a counterclockwise direction. So M just talks about how much my line slants, which direction, whereas B is going to tell us where is the starting point, what is the y-intercept. Remember, our B is the y-intercept. Where is this graph? Where does it touch the y-axis? Okay. But what's really important, and this might be a little different, this linear function where it goes through the origin. This is a very special type of linear function. So you might want to write this down somewhere. Linear functions with a slope of 1 that pass through the origin is called a linear identity. So a linear function, if it, oh crap, that's not what I was trying to do. I was trying to type here. Too many programs. If it has a slope of 1, a y-intercept of 0, y-intercept of 0, I should have been having some typing issues. Y-intercept of 0, it is called a linear, linear identity. Has a called a linear identity, but it must go through the origin, and it has a slope of 1. We are going to use this a little bit later when we start exploring inverses and opposites of functions. I'll talk about how the linear identity ties into that. But right now, like say, constant function, straight line, linear function, y equals mx plus b, but the special one of a linear identity. And the third type of function that I want to talk about right now is called absolute value function. Okay. It's an absolute value function. So, anybody remember anything about absolute value?
Isn't like absolute value the value of that number?
Yes, absolutely. Absolute value is the value of that number. Any special characteristics about it? It's something that you might remember? Anything that anybody remembers about absolute value? All right.
Is it how far it is from 0?
That's precisely what it is. It is exactly how far is a number from 0. Absolute value is how far is a value from 0. And because absolute value is distance, we're talking about how far something is. Distance is Distance is never negative. Okay, so absolute value cannot be negative. So in black, I have a, let me close this for a second. All right, so in black, this is a function of absolute value. If you see these bars like this means the absolute value. This will be read, the function of x equals the absolute value of x. So the output is whatever is the absolute value of x. So those bars mean absolute value. So if I use x as, for, let's say, -5, what I want to know is how far is -5 from 0? It's 5 units, right? That's absolute value. But if I want to know how far is +5 from 0, it too is 5 units. So the absolute value cannot be negative because you cannot have a negative distance. Distance, by definition, cannot be negative. You know, when I, if I drive somewhere, if I drive to go visit my family back home, I drive 200 miles. When I come back to Columbus, I don't drive negative 200 miles. It's still a positive distance. Distance is always positive. So absolute value, because its distance is always positive. So no matter what, absolute value is going to be positive in the base function, okay? So that's important to know. And because absolute value is never going to be negative, it's always going to make a shape like a V. It's always going to make a V shape. It could be a wide V. It could be a narrow V. It could be upside down. We could move it around, but it's going to be a V shape. There is no exception to that if it's absolute value. And just to kind of prove that or verify that, I like proofs. Open graph right here. I'm going to pull up this absolute value, just kind of take that black one off for a second. Take that for a second. So this is still absolute value. This is saying A times the absolute value of x minus b increased by c. So no matter how I move, if I change A, it might make my V go down or skinny, or it might make it go up, it might get wider, but it's still the V. It's still, it still has that shape of a V. It might have got, like I say, you can make it wider or narrower, but it's still a V. The value B, and this is something, trust me, we'll go back to transformations. Right now, I just want you to know absolute value is always going to make a V. You could shift it. This value just tells us how far we need to move it from the left or to the right. But it's still a V. And the C, that's just going to make it move up or down. But it's still going to keep that same shape, okay? So the constant function is always going to be a horizontal line. A linear function is going to be straight. It won't have any curves, but it might be, it might be angled. It'll be diagonal often. An absolute value is going to make a V. Some variation of a V, but a V. Okay. All right. Let me pause. All right. Any